Hello, welcome again. We are solving some questions of heat transfer. The topic is one dimensional heat conduction. Question number 24 and 25 carries a common statement. The statement is a copper tube of 20 mm diameter, 1 mm thickness, and 20-meter long, thermal conductivity 400 watt per meter per degree Kelvin, is carrying saturated steam at 150 degrees Celsius. Convective heat transfer coefficient is equal to 150 watt per meter square per degree Kelvin. The tube is exposed to an ambient temperature of 27 degrees Celsius. The convective heat transfer coefficient of air is 5 watt per meter square per degree Kelvin. The glass wool is used for insulation. Thermal conductivity is equal to 0.075 watt per meter per degree Kelvin. If the thickness of insulation used is 5 higher than the critical thickness of insulation, then question number 24, rate of heat lost by the steam. Option A 38.69 watt per meter, option B 39.11 watt per meter, option C 41.12 watt per meter, option D 32.11 watt per meter. Question number 25, rate of steam condensation in kilogram per hour. Enthalpy of condensation of steam is 2230 kilojoule per kilogram is option A 0.0624 kilogram per hour per meter, option B 0.0514 kilogram per hour per meter, option C 0.0321 kilogram per hour per meter, option D 0.099 kilogram per hour per meter. So now here outside radius of the copper tube is given as 10 mm, and thickness of insulation or diameter is given as 20 mm, or thickness of insulation is given as 1. Okay, so inner radius of copper tube is thickness of the copper tube is given as 1. So the inner radius of copper tube will be 9 mm. Okay, and thermal conductivity of copper pipe is 400 watt per meter per degree Kelvin. Convective heat transfer coefficient is your 150 watt per meter square per degree Kelvin. Thermal conductivity of glass wool is your insulation is added, that is of glass wool, and thickness of thermal conductivity of glass wool is your 0.075 watt per meter per degree Kelvin. And convective heat transfer coefficient of air is outside air is 5 watt per meter square per degree Kelvin. So now the critical radius will be found out only on the basis of that insulation, and conductivity of insulation is given as 0.075. So R3 is your kg by h naught. There is 0.075 by h, or 0.015 meter, or 15 mm. So that is the critical radius of insulation. Okay, and outer radius of insulation is 5 mm more than the critical radius. So R3 is your 15 plus 5. So this is R3 is your this is your R2. This is your R3. Okay, R3 is critical thickness, and R2 is that outer radius of copper pipe. And now thickness of insulation is 5 mm. So R3 will be 15 plus 5, that is 20 mm. So thickness of radius of insulation is the critical radius is 50 mm. So as 5 mm more than the radius is outer radius is 5 mm more than the critical radius. So so outside radius will be 20 mm. Okay. So now R1 is 9 mm, R2 is 10 mm, and R3 is your 20 mm. Okay, because this is your inside copper tube, this is your outside copper tube, and this is your critical radius. Okay, so now R1 is the resistance of this part, inner part, and R2 is the resistance of this part, and inner convective resistance, and R2 is resistance of the copper tube, and R3 is resistance of insulation, and R4 is outside resistance. Okay, so adding these as these resistances are in series, so equivalent resistance will be R1 plus R2 plus R3 plus R4. So it will be 1 by 2 Ri Hi or 1000 by 2 by n 9 by 150, and this is your ln 10 by 9 divided 2 pi kc, and ln 20 by 10 divided by 2 pi 1075, and this is your 1000 divided by 2 pi 20 by h, 20 into h. Okay, so solving this we have equivalent resistance at 3.179. Okay, and heat loss is temperature difference by RT, so that is 150 minus 27 by RT, or 150 minus 27 by 3.719. So heat loss will be at 38.69 watt per meter. Okay, so now total, that is the heat loss uh, in watt per unit length. Okay, because we have not taken here length. Okay, we are taking only the radius. Here L should be, we have taken L as 1 meter, so that is the heat loss watt in watt per meter. Okay, and the total heat loss in 1 hour, that is the watt means joule per second, so that is the heat loss in 1 second uh, per unit length, per meter length. Okay, and in 1 hour uh, the heat loss will be converting it into 0 kilojoule dividing by 1000 and multiplying by 3600 to convert it into kilojoule per hour. Okay, so that is the total heat loss in kilojoule per hour per meter. Okay, and now enthalpy of saturation is also given, that is 2230. So this is the heat loss uh, uh, in kilojoule per hour per meter, and if we divide by kilojoule per kilogram, okay, so then it will be kilogram per hour, so that will be the mass that is that is condensing in 1 hour and in 1 meter in unit length. So answer is 0.0624, and heat loss rate is 38.69. So answer to question number 24 is A, and 25 is also